Hello, math students, and welcome back to Module 1, Ratios and Unit Rates. This is Lesson 8, and the title is From Ratio Tables to Equations Using Value of a Ratio. Our goal for today we are going to learn how to use the value of a ratio to write and solve equations. And you need to remember that a value of a ratio tells you something per one. So we're trying to figure out the amount per one. The question that I want you to be thinking about during this lesson is, how does the value of a ratio change based on the numbers being multiplied? Okay, there are some things that we need to remember, and specifically, I would like us to think about and remember, how do you find the value of a ratio? So we made a little ratio table, because you guys are now familiar with ratio tables, and we're calling it boys and girls. And then we have a whole bunch of ratio relationships right here. For every 20 boys, there are 16 girls. For every 5 boys, there are 4 girls. For every 25 boys, there are 20 girls. For every 10 boys, there are 8 girls. For every 15 boys, there are 12 girls. So we just need to build our table. So for every 20 boys, there are 16 girls. Okay. For every 5 boys, there are 4 girls. For every 25 boys, there are 20 girls. For every 10 boys, there are 8 girls. And for every 15 boys, there are 12 girls. So now what we want to do is we've got to figure out what would be the per one. Okay? So if we're trying to figure out for one boy, then we're going to figure out, okay, how do we get from 20 to 1? So we would divide 20 by 20, and that would give us 1, and then we have to take 16 divided by 20. So another way to write 16 divided by 20 is like this, okay? And that can simplify to 4/5, right? Okay, and then on this one, you're going to say, how do we get to 1 on the 5? Well, 5 divided by 5 is 1. So what you do to one side, we have to do to the other. So let's backtrack for a minute. 20 down to 1 is divide by 20, divide by 20, because what you do to one side, you have to do to the other. Divide by 5, divide by 5, and 4 divided by 5 is 4/5, because you take 4 and you divide it by 5, and you get that 4/5, okay? 25 divided by 25 gives you 1, so what you do to one side, you have to do to the other, so we do 20 divided by 25, and 20 divided by 25 looks like this, and it can simplify, dividing both of them by 5. 20 divided by 5 is 4, 5 divided by 5 is 5, and you notice that on each one, we're getting 4/5 so far. Okay, so let's keep going. How would you get 10 down to 1? You're going to divide by 10. What you do to one side, you have to do to the other. So that gives us 8 divided by 10. And 8 divided by 10 looks like this. So we have 8/10, which if you look at 8/10, it can simplify by 2. 2 goes into 8 4 times. 2 goes into 10 5 times. So again, we have 4/5. And then the last one is we're trying to get 15 down to 1. So you're going to divide 15 by 15. What you do to one side, you have to do to the other. So we're going to take 12 and divide it by 15. So that would give us 12/15, which if you simplify that, 3 can go into 12 4 times. 3 can go into 15 5 times. So if you look at each one of our ratios that's created, boys to girls, all of them will simplify to 4/5. So we now know that the number of boys is 4/5 of the girls. Okay, so the number for every one boy, there are 4/5 girls, is how we would say that. So the number of boys is 4/5 of the girls. I actually think that that's the girls one. The number of girls is 4/5 of the boys. And the reason why we say that is because when there is one boy, right, one boy there is 4/5 of a girl. And the reason why we know that is because we checked all of these when we took the boys down to 1. So for every 1 boy, there is 4/5 of a girl, right? And now the way you change it is, what if we wanted to take these to 1? And you do the same process, except we work backwards. So you're going to say, okay, to get the girls to 1, you would do 16 divided by 16. And then you would do what you do to one side, you have to do the other. So you would do 20 divided by 16. And then you would go 4 divided by 4 gives me 1. So 5 divided by 4. And then 20 divided by 20 gives you 1. So 25 divided by 20. And then 8 divided by 8 gives you 1. So 10 divided by 8. And then 12 divided by 12 gives you 1. So 15 divided by 12. And then we do the same process. What is the number that can go into both of these evenly? I would say 4, so you get 5/4. And then look at that, you have 5/4 here. This one can be simplified by 5, which 25 divided by 5 is 5. 20 divided by 5 is 4, so again you get 5/4. This one simplifies by 2. 10 divided by 2 is 5. 8 divided by 2 is 4, so 5/4. And then divide them by 3. 15 divided by 3 is 5. 12 divided by 3 is 4, so 5/4. So now when the girls is a 1, then you know that the number of boys is 5/4 the number of girls. And so we know that this answer is true when there are 1 girl. Okay, we know that this answer is true when there is 1 boy. Okay, and that's how we have to remember it. So the number of boys is 5/4 the number of girls, and the number of girls is 4/5 the number of boys. And the reason why we're trying to figure that out is because this, kiddos, is what we call the value of a ratio. Okay, and that's not new information, that's a review. We've been learning about values of the ratio. The values of the ratio are just when you take the ratio and write it in fractional form. Okay, and these two happen to be simplified fractional form. 20/16 makes 5/4. 5/4 makes 5/4. 25/20 makes 5/4. 10/8 makes 5/4. 15/12 makes 5/4. If you do 16/20, it equals 4/5. 4 divided by 5 is 4/5. 20 divided by 25 is 4/5. 8 divided by 10 is 4/5. And 12 divided by 15 is 4/5. And so that gives you the value of the ratio when you have either the boys being a 1 or the girls being a 1. And so you're finding your unit rate per 1. So it's kind of a little bit of a review to help you remember. It can be complicated, but if you just go slow and remember what we were talking about when we're trying to find per 1, then we're good to go. So let's try another one. It's called practice time. Jorge is mixing a special shade of orange paint. He mixes 1 gallon of red paint with 3 gallons of yellow paint. So we have 1 gallon of red paint, and we'll just draw it. Here's the gallon of red paint right here. Okay, a whole gallon with 3 gallons of yellow paint. So here's 1, here's 2, here's 3, and they're all yellow, and they're all gallons. Okay, so now we can visually see the representation of 1 gallon of red paint for every 3 gallons of yellow paint. And then we're going to see what they have us do with it. So it says, now that we have a picture in our mind of what we need, we're going to make a ratio table. So here's the ratio table, okay? And it says, make a ratio table for the color orange. So 1 gallon of red paint for every 3 gallons of yellow. Okay. Well, what if we have 2 gallons of red? So what if I had another gallon here? How many yellow would we have? And if you said 6, then you would be correct. Because if we have 2 reds, then we have to have 6 yellows. Okay. Well, what if we had 9 yellows? So we have 3 here, another set of 3 here, and another set of 3 here. How many reds would you see? And hopefully you're starting to see the pattern. That would be 3, okay? And then what if we had 12? So we had yellow, 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 and one more set of yellows. So how many red in total would you see? If you said 4, then obviously you're starting to see the pattern, which is what I need you to do. What if we had 5 reds? If we had 5 reds, how many yellows would we have? If you said 15, then you are correct. So here's the question. This is what we have to figure out. For every red that you have, for every red gallon that you have, how many yellow have to go with it? So if I picked out this red and I'm trying to make orange paint, how many yellow would I have to have with it? So we're going to say that you have to have 3 yellows. So any number of red means that you need to have 3 yellows that go with it. So any number of red, then that means you have to have 3 for each one. So I have 1 red, that means I have 3 yellow. I have 2 reds, I have 6. I have 3 reds, I have 9. I have 4 reds, I have 12. I have 5 reds, I have 15. So any number of red means that you have to have 3 to go along with each red that you have. So then we can answer this one. Okay? So if we have 3 yellow, everybody, how many red did we have? 1. Okay? So we're going to say that for every 1 red, you have to have 3 yellow. So we make that into a ratio, right? And we get 1/3, right? For every 1 red, there's 3 yellow. Okay, for every 2 red, there are 6 yellow. So that would be 2/6, right? For every 9 yellow, there has to be 3 red, so that would be 3/9, right? And then for every 12 yellow, we'd have 4, so that would be 4/12. And then for every 5 red, you need 15 yellow, so that would be 5/15. And then for every 1 red, there has to be 3 yellow, so that would be, this could have a coefficient of 1, because 1 times R is R, right? So that would be 1 R per every 3 yellow, like that. Okay, so now let's look at it. When red is 1, that means that we'd have 3 yellows. Okay, so it means that the red paint is 1/3 of the yellow paint. Okay, and the yellow paint is 3 times the red. Okay, and that kind of makes sense. Red paint is 1/3 of the yellow paint. So look at it. It is 1/3 of the yellow paint, whereas the yellow paint is 3 times that of the red. Okay, 3 times, because there's 3 times the number of red every time. If you take 3 times 1, you get 3. If you take 2 times 3, you get 6. If you take 3 times 3, you get 9. If you take 4 times 3, you get 12. If you take 5 times 3, you get 15. If you take R times 3, you get 3Y. Okay, so the yellow paint is 3 times that of the red. The red paint is 1/3 of the yellow paint. Okay, and so the relationship is the value of the ratio. The relationship is the value of the ratio. So remember, when you're doing a value of the ratio, you just write your ratio table as a fraction. So I have 1/3. I have 2/6, which simplifies to 1/3. I have 3/9, which simplifies to 1/3. I have 4/12, which simplifies to 1/3. I have 5/15 that simplifies to 1/3. And then I have 1/3 of red. 1/3 is the relationship of every 1 red to 3 yellows. Okay, so the relationship is the value of the ratio. Okay, so then the last thing that we need to go over very quickly is making an equation, because there's an equation that we use to help us write this consistently every time. And the equation is, remember that you have to include an equal sign. So remember that an equation is an expression with an equal sign. And so what we have is when we're looking at our red is equal to 1/3 of the yellow, because look, for every one red, we have 3 yellow. So if we're doing a comparison of just the red means that it would be equal to 1 out of the 3. Whereas the yellow equals 3 times the red, and if we look at that, we have 1 red, we have 3 times that, so that means we have 3 of them, okay? So these are the equations that we can use to help describe our scenario. The red is 1/3 of the yellow, which is true, and the yellow is 3 times the red, because there's 3 more of them than there are red, okay? So hopefully that helps you, okay? The important thing to remember is we go back to our goal for today, and it says, today we are going to learn how to use the value of the ratio to write and solve equations, which is what we just did. How does the value of the ratio change based on the numbers being multiplied? I would say it just changes to what you do to it. So if you double it, then it would be doubled. If you triple it, then it would be tripled. If you multiply it by 4, then it would be quadrupled. So the value just becomes an equivalent ratio, whereas the value stays exactly the same, but the numbers represented can be different as long as it comes up with the same value. Okay? I hope this wasn't too confusing. If it was, then we can spend a little more time in class clarifying things. But just remember that the value of the ratio is where you take the ratio itself and write it as a fraction. And then it also is reminding you that it has to be per 1. All right, kiddos, that's all I have for you today. Talk to you soon. Bye.